All right, hello. No, we're here. We're here. Okay, we're doing a thing. We're going to be doing assembly day 5. And in assembly day 5, we have what do we need to learn. We actually mostly did this last stream, but we only got partway through the converting a number into a string. You would think it would be super easy. And I remember we being a little bit more detailed. We kind of got into some details here that you see on the screen here that it ended up getting stuck on a couple of things because we were unsure how it worked. And then we figured it out, and we had some aha moments. We had some breakthroughs. It was like, oh wait, we can read it now. Right here, this part right here on the screen. It was amazing. I was reading this. I'm like, wait a second, I understand this now. It totally makes sense, right? Because now we understand how operators work, or some of these operators, right? Some of these like the sub, like subtract. So you've got it's kind of like this, right? So it looks like this. It looks like this. X3 equals X3 minus 1, which is going to like decrement itself, right? It's a decrementing. Hey, Astrid. Hey, hello. Good to see you. Hi, question mark. What do you mean, hi, question mark? Hello, we're doing assembly day 5 today, where we're going to walk through and we're going to make sure that we finish it. We want to learn how to make sure to get a number into a string. I know it's like one of the easiest things you would think, because you could just, in Python or any other language, you just say like, dot to string, right? Dot to string, something like that, or an str in Python, right? These kinds of things. Still on assembly, yeah, I know. Well, we didn't finish yesterday. Actually, you know what? Before we were doing assembly, I wanted to look at, I pulled this article up because it just came out. Ashford, this just came out. Here we go. So let's save this for later. We're going to save this for later. This came out just today, Agent Payments Protocol, and I was really curious about what this was. And I have the GitHub repository up right here. And I wanted to walk through what it looks like and what it means. I was just really curious because look right here, 12 hours ago, Google just released this. Hey, Christopher Smith, hey brother, made it this time. Cool, great, happy to have you here. Excellent. We're going to do a couple of things today. We're going to do assembly day 2, or day 5 rather. I don't want to say day 2. Then we're going to, because AP2. I was thinking AP2. This is agentic payment protocol thing that Google just came out with. And I'm super curious about it because it's like 12 hours ago, they just dropped it. And I was like, Love Gupta. Good morning, sir. Hey, happy to have you here. Thank you for the likes, you guys. Appreciate it. Going to do a couple of things today. We've got a plan. So the introduction, what we're going to do today to get started, is we're going to walk through the AP2 protocol that Google just came out with. And it's a repository contains code samples and demos for the agent payment protocol. And I guess P2 stands for 2 Ps. They could I get it. If they wanted to have an acronym, they couldn't just do this, right? They couldn't just go APP, because that already has a meaning. It already has a meaning. So they had to say AP2. That's what it is. Okay, so that's why they said AP2. It stands for Agent Payment Protocol. And so I just wanted to walk through it really quick. Here we go. Let's see here. The samples directory contains a collection of curated scenarios meant to demonstrate the key components of Agent Payment Protocol. And I want to walk through some of the code. And what's curious is if it's an Agent Payment Protocol, why does it require a Google API key? This is weird, right? Because if it's a protocol that's typically more of an open standard, and it seems like they're completely heavily, there's a Google API key is required. I'm kind of curious. To run a specific scenario, follow the instructions in its README MD. It will generally follow this pattern. Navigate to the root repository, cd to the AP2, run the script, install dependencies, and start the agents. Interesting. Okay. So navigate to the shopping agent URL and begin the engagement. And then you can just install the packages like this. And that's it. That's the whole README. There's nothing else to it. All right, let's look at some of the samples. I was kind of curious to look at some of the samples. Let's check this out really quick. All right, so there's an Android and a Python. And Python's easy to read, so let's do that. So we got a Python README here. Understand these samples can do scenarios directory for the detailed examples. Dive into the implementation and review the code in the source directory. All right, so is that here? Okay, in the source directory, here we go. Okay, so return to the main samples directory to see examples in other languages. All right. Well, they only have Android and Python, so let's check these out really quick. So let's go to source. What's in common really quick? Oh, a whole bunch of stuff. They have a whole bunch of things in here. What's going on? Server Pi, a bunch of, what do we got here? Agent execution, simple request context builder, Starlet app, a default request handler, In-memory task store. All right. What else we have? Middleware base. UV corn. Okay. So it's got UV corn. So it's going to be, this is the web server. This is going to be the web server framework that they're using. Interesting. Okay. Run agent blocking. Launches UV corn server. Okay. An agent for blocking the current thread. I'm just kind of curious to see what's going on in this. What is even happening here? What is this protocol? Ashford, I'm interested in your entertaining assembly in your sniper game for voice command recognition. Let players speak commands like engage target, switch to thermal scope, reload weapon. That sounds actually like a really good idea. That would be really cool. That's like a hands-free game, right? So you just sit back and you just kind of enjoy playing the game, and then there's no buttons, and all you have to do is just yell it out loud. That actually kind of sounds like a really fun game. Mohammed, hey, good to see you. Welcome back. We're looking at the AP2 protocol that Google just released, like just today. They just released it. 12 hours ago, they open sourced the GitHub repository. I'm really curious what it means and what this is. And we're just kind of reading through some of the code here, just kind of walking through it. Ensure the response body, all the responses UTF-8 encoded. Okay. What is build Starlet app? All right. So create and return ready to serve Starlet. What is Starlet? What is this? I don't even know what that is. What is Starlet AGI? Starlet is a Starlet framework, a lightweight ASCII framework toolkit, which ideal for building async web services in Python. Oh, okay. It's production ready and gives you the following lightweight, low complexity HTTP web framework, WebSocket support, in-process background tab. Okay, so it's kind of a nice little framework. It cannot be faster than it. Okay, Starlet uses UV corn and cannot be faster than Fast API uses Starlet. Oh, does it? Wait, really? Wait, hold on. I had no idea this whole time. All right, Fast API uses Starlet. Oh. Wait. The same way that Starlet uses UV corn, so it stacks this whole time? Wait. So Starlet uses UV corn and Fast API uses Starlet. Oh, I didn't know that they had these dependencies, you guys. I thought they were their own separate things. This is crazy. Starlet is a fast and minimal design built to low overhead and modularity. Okay. Async first. It's optimized for async IO. Okay. Yep. That makes a lot of sense. Ideal for real-time APIs and WebSockets. Okay. So now we know more details now. We're getting information. We're learning things. That's all you have to do is read code. That's all you have to do is just read the code. And then you will learn new things that you never knew before. The agent card, objective describing the agent executor, a process, uses agent-to-agent requests. All right, so they're so hey, thank you for likes, you guys. Appreciate it. Let's see. The more code we read, the better we understand it. Let's just got to keep going. Some middlewares. We got some cores middleware. Cross-origin request. Okay. Cross-origin request service. Okay. And then it just says allow everything, basically. Okay. All right. So that's I think that's just like the boilerplate. Simone, hey, how's it going? Welcome in. We're looking at the new agent payment protocol that just released 12 hours ago. So Google just came out with this. And we're walking through. We're seeing what's going on with it. We're really curious. And we are learning some stuff here. Retrying payment, validation. Let's just kind of see what they got in validation here. Very small file. There's nothing in validation. They're not validating anything. This validation. Thank you for the likes, you guys. Appreciate it. We're just doing a quick look through here on the agent payment protocol, and there's this validation file. Validates the payment mandate signature. Does it actually? Payment mandate user authorization is none. Then raise error. Okay, that's great validation, isn't it? If there's no authorization, then throw an error. Raise value error. User authorization not found for payment mandate. Excellent validation, you guys. Really good. It's robust validation. Hey, Jatin. Hey, Jatin, how's it going? I really like this type of live stream knowledge. It's so knowledgeable. Thank you. Appreciate it. Awesome. Appreciate it. Thank you. Mohammed, how often you restart your PC? The uptime is 9 days. Is it? It can go for way longer. It's been months since I've restarted. But this is a Unix based system, so you never really have to restart. I've had an uptime of 7 years on a server before. 7 years on a server. Obviously, you can patch. It's been patched, and you can do hot load patches. But 7 years, that's a long time to have a system up. That lets you know the stability of Linux and Unix based systems, doesn't it? You're in a whole new world. So if you've ever been running on like a Windows, for example, you kind of are used to restarting the PC every so often. But and not in this in the Unix world, you actually got some stability. You got some stability. Don't need to worry so much about it. All right. So we got this weird validation file that does not validate very much. What's in our artifacts file? What's this? What do we got here? All right. So there's actually some meat to this file. Typing, agent to agent, types, artifacts, base model, pydantic. Okay. Got some pydantic in here. A T, type var T. Okay. This kind of abstraction frustrates me right here. What you're seeing right here on the screen. It's why. Like, it's not that useful. All right, here. All right. Find canonical objects. Find all canonical objects in the given type of artifacts. A list of artifacts, the type of data part to search, model of the canonical object for search. Okay. A list of canonical objects gives in the type of the artifacts. What kind of abstraction is this? It's kind of, here's the deal. Here's one of the problems with computer science, you guys. Check this out. It's kind of a lot of fun. There's a lot of entertainment when you come to architecting a design of a program or an algorithm or an architecture. How do you want to lay out the abstractions in your infrastructure? Often you want everything to have like a nice, tidy, dedicated file, and it has its own roles and objectives. But the problem is that you start abstracting to the point where you're saying like data parts, item, data part, return item. Like, look at this. This is too abstract. We've gotten to the point where if you're naming variables just vanilla like data, you've abstracted too much. This is too far on the abstraction scale. You need to keep things simple. You don't need to abstract. If you're currently abstracting to this level, you've gone too far. It's unnecessary. It's not needed because you won't always need it to use it. Because there's nothing happening here. It's just weird data type stuff. It's not necessary. So it would be better just to have one giant file and have everything in that file and just, move forward with it. Sure, you might want to abstract things like reusable like functions and stuff like that you could then import that you use a lot within your main file. Though in that case, hey, Ms. Guy, hey, how's it going? Thank you. Welcome to the stream. Said hi. Thank you for saying hi. We're currently walking through Agent Protocol 2, which was just released 13 hours ago. This just came out 13 hours ago by Google, and we're just checking it out. We're seeing what's going on. What's in the init file? Anything in here? Nope. Utilities leveraged by various agents. Okay. So they have, let's get out of the source file. Let's go into roles here. Let's see what this is. All right. So we've got some actual roles here. We've got a credentials provider agent, a merchant payment process agent, and a shopping agent. Let's see the shopping agent. Let's look at there's sub-agents for the shopping agent. What's going on here? All right, here. Mohammed, how's it going? Do you know Kubernetes? It's kind of like asking if I know Kung Fu. Yes, Kubernetes. Definitely know Kubernetes. We've got services, different types of services in Kubernetes. You've got your pods. You've got your scaling, vertical and horizontal. You've got routing, service discovery. You've got the etcd. You've got Nginx. There's so much to talk about. Why do you ask about Kubernetes? That's actually a really good question. Kubernetes, did you know, is written in Golang? It's written in Golang, the Go language. I guess. EJ, how's it going? What type of code are we analyzing? We're currently looking through. So we have a plan today. We are going to be doing assembly. So we're going to, but that's a little bit later. Before we do assembly, we're jumping into Python. Google just released this 13 hours ago, a agent-to-agent protocol. And we're currently looking through some of the code just to see what's going on. Joined late, guy with glasses. Hey, how's it going? Welcome in. What are we doing today? We've got the AP2 protocol released by Google. We're just walking through it real quick. I'm curious what it's about, what's going on, like why does it need extra stuff? Like the Google ADK powers the shopping agent, chosen for its simplicity and efficiency in developing robust LLM agents. Okay. So the shopping agent's role is to engage with the user, find products offered by merchants that fulfill the user's shopping intent, and then help complete the purchases of their chosen items. Interesting. Okay, so I think the idea behind this, hey, Rudy, hey, hola, welcome in. We're currently going through agent to agent here, or not agent to agent, but there is agent to agent involved in the AP2 protocol, which is agent payment protocol, which Google, they're thinking ahead here. They're like, these agents, they're going to be buying things for us. They already doing it today. Wouldn't it? I mean, it's so much nicer. Oh, when you go on the internet and you have to like press buttons and make decisions. Isn't it nicer just to ask someone to do that? Like, hey, just I want some butter, some sog paneer or some butter paneer or like tikka paneer, right? And then maybe some naan. That sounds really good. I think that would be amazing. I'd love to have EJ. Do you think agents will have full autonomy in shopping for its users, like make purchase without permissions? Yeah, I think so. I think that's our future. That is our future. Because I kind of want it. I know there is like maybe a zen in shopping. It might be an activity that's fun for humans. So that activity will continue probably. Though in other scenarios, shopping is a task. It's an effort that you have to put in because you want to make the right decisions and you don't want to. EJ, wow, yeah, I know, it's amazing. We're in the future, aren't we? And so having an agent make those decisions for you, and you just give it sort of parameters, like, I'm hungry. I want, a burrito. Maybe you're into you want some Mexican today, and you want, and it knows your previous purchases, what you really liked, what you didn't, and it can just go from there. I think that sounds really cool. Because then you don't have to work and you don't have to make decisions, and it can make compromises for you when there needs compromise. When, like, for example, they don't have any of the beans today, so you have to choose something else. So I think wait, hold on a second, guys. But a lot could go wrong with the scenarios. I know, you're totally right. I mean, so that's also one of the things. Is when you're making decisions, when you yourself are making decisions, you don't want things to go wrong. So you spend a lot of effort and energy into it. And it might be worth it for you to give that up and give it over to an AI agent, even if it can get it wrong, because it's worth it to you. I think that's the answer. I have a question. Do you know in what use case is it required to use assembly? Rudy, you're asking the right questions. You're asking the right questions because, never. I think the answer is you don't. I think the answer is you don't need it. Gmail user, thank you. Hi, my friend. You were awesome. Oh, I appreciate it. That's so cool. There we go. Fantastic. Thank you. I appreciate that. Look at that. That's so cool, Gmail user. I appreciate that. Very, very, very generous. That's very generous of you. Thank you. I appreciate it. Yeah, we're gonna be looking through this code today, and we're gonna be having fun. We're gonna be reading the code, and we're going to be learning. That's what we're gonna do. We're gonna be learning. That's the idea, and that's our main goal. So as software engineers, daily task requires us to learn as much as we can, so we can be effective at our job because things change so often. Gmail user, thank you. Appreciate it. That was very nice of you. That was very kind. I definitely like that. That's really cool. That's very generous. I appreciate it. Yeah, software engineers, we have to learn. And so we learn by reading, and it's a lot. You're my favorite coder. Thank you. Oh, that's so cool. I appreciate it. Yeah, we'll be, that's the plan. So we'll be coding on the weekdays, and we'll be making it happen. There's so many cool coding activities we can do. But, we've got a lot of ideas that are coming up here in the future. Okay, so let's see here. When do you need to use assembly? Rody, the answer is you don't. You don't need to use assembly anymore because but it's fun, and we get to learn from it, and you gain insight and knowledge to how these programs work. So that is why you want to learn assembly, but you don't need to use it ever again because we've got higher level programming languages. All right, Mohammed, let me get caught up with some of the chats here. I missed some of your chats, you guys. Hold on. Here we go. I have a question. Why is there double hop in Kubernetes? If I expose service with a node port, I can reach it through any node in my cluster, but internally reroute to the correct node where pod is. So it depends. What kind of network you're on, or it depends on your network, right? And what maybe you're on a VPC? Are you on a subnet of sorts? So double hop in Kubernetes if you expose a service. So you're using a service exposure on a port with node. Yeah, well, the idea is service discovery. So Mohammed, it's the idea is service discovery. If you use a service and you expose through a port and you've got a separate port, so node is on 3000, right? You've got node on port 3000, and then you've got Nginx, which is running on like maybe port 8080 or port 443 or something like that. Nginx is going to be able to load balance across your pods. Your pods, a node on port 3000 will be able to be scaled up like horizontally across more nodes, or more like servers essentially, right? So you scale up more pods. Nginx will then add those upstreams into its rotation of round robining. And so that allows you to scale up. That's why there's that level of indirection. You want it. It's good for you. You like it. It makes your life better. And so that's the answer. That is the answer, because you want to be able to scale up your pods and have the Nginx deal with the service discovery of those new pods and add them into rotation. As soon as the pods come online, that's why. That's what the service is. That's what that's for. All right. Let's see here. Jayton, all right, catching up with some of the chats here, guys. In reverse engineering assembly foundation is needed. Yeah, it is. That's a good point. So if your job or if your task is to reverse engineer, when you do that, because everything's in machine code, right? So it looks like this. We're here. Let's do this. So you see code that looks like this. Set wrap, right? It looks like that, you guys. And then you convert it back into assembly, and you get all these instructions over here on this side of the screen. So you would need to understand how those things work. In assembly, with the knowledge of it, now you can decode programs, even if they've been compiled, you guys. Isn't that cool? All right. Assembly is, let's see here. Assembly is needed for making compilers and sometimes optimizing embedded code. It isn't 100% useless. Yeah, you're totally right. So there's a lot of uses. For the most part, the majority of software engineers never even have to know about it, because I've been doing this for a while. I've been doing software engineering for many, many years. And I'm only just now learning assembly. Like I've used it before and not really knew what I was doing, but now here we go. Now we're making things happen and we're learning assembly, you guys. It's really cool. And it's a lot of fun. Like, look at this. What is this? The CBNZ. Like, what is even that? What is CBNZ? We found out yesterday that it's a compact statement. It's a conditional branch when the number is 0, right? Conditional branch when the number is 0. Isn't that crazy? The more you know, it's great. Zach, hey, Zach, how's it going? Hey, bro, remember where I am from? Zach, actually, that's a really good question. It's kind of hard. Did you say, I'm going to get it wrong, but it could be Nepal or India? Like one of those two? I don't know. If you're still here and you heard me read, because I'm behind on some of the chats here. If I'm still here, did I get it right? Did I win? Is that where you're from? I'm trying to remember. There's so many things to remember. All right, Mohammed, is this approach similar to the MCP protocol for multi-agent communication? Yeah. So we were looking at the. Yes, it is. You're totally right. This is multi-agent communication. They do have agent-to-agent built in. India. It is India. Okay, Zach, it's India. Okay, excellent. All right. I gave 2 answers, but one of them was right, so I get half credit, right? Is that 50%? Do I get half of it right? Did I get at least 50% credit on that, or is it like a all or nothing? Is it all or nothing? Let me know. Guy with glasses, any good sources to learn assembly? I barely passed this course in my college. Don't worry. Yeah, no, I understand what you're describing. Any good courses? I don't have any idea if there's any good courses. We're learning it without doing courses. We're just reading it. That's what we're doing. We're reading it and then we're figuring it out and then we're playing with it. Like we're hacking it. Like we're learning what each of these things do. And like, so for example, we comment this out. We comment that out and then we see what happens and we see if the compiler works. Hey guys, Steve Sanker. Hey, how's it going? Welcome in. SN. Hey, Gazori. Hey, welcome into the stream. Thank you. And then Mohad Mohammed. Nice explanation, bro. You understand it? Okay, cool. So that was the Kubernetes service and multi-port for service discovery. Excellent. Jambuster. Hey, Jambuster. Hey, this is a long bay with the assembly. Yes. Hey, that's it. A long bay with the assembly. I'm not quite sure what you mean, but I'm assuming that there's a lot. Yeah, there's a lot of assembly and there's a lot to learn. And so it's going to require many days, you guys. It's going to return a lot of days. Okay, so I think we're almost caught up with the chat here. Oh, Coursera, Gmail user. That's a good idea. Coursera. Yep, you're right. Coursera will probably you can be learned from Coursera. Probably. Let's actually find out. Let's find out really quick. Let's find out. Coursera. Assembly language. Let's see if it gives it. Coursera. Let's see. Coursera. Z architecture. Assembly language. The basics. Part 1. 6 modules. Intermediate. Look at that. Start here. More details. Show details about the reading. 15-minute reading. So you guys, the answer, Coursera has some stuff, but you probably have to pay for this, right? It looks like there's a money required scenario for that. It looks like there's a money required situation. But yeah, but we're doing it for free, you guys, because there's the assembler is for free. It's for free, you guys. Hey, Lauren, let me see here. Laurentiu, Petre. I'm trying to say your name, but I completely am not able to say. Hey, Not Owen, welcome. Let's see here. Not Owen, low level learning teaches assembly. I think Not Owen. Yes, exactly. You're totally right. Good to see you, Not Owen. It's good YouTuber for security. Yeah, I think so. I think you're right. I think you're totally right. Will we be checking up more on the API shopping agents? Yes, we're going to do that. So we wanted to do that as the first thing that we're doing here today. And then we're just going to read through a couple more of the things. And I'm looking at something here on the screen that caught my eye, and I really want to talk about it for a second. I want to talk about this. What about programming language that's internally compile to different programming languages like Java, Golang, etc. is possible? So those languages, oh, right. So they compile to a sort of not direct machine code, but what is it called? Virtual machine code, right? Java virtual machine? Is that what that is? Java virtual machine? It compiles, so that way it makes it portable. And that's the whole point of assembly too. In other languages, like assembly is not portable across CPUs because there's different architectures. There's RISC, there's ARM, there's x86, and there's others. There's others out there. And the assembly operators don't exist in all of them. And so when you're compiling a high-level language like C, you wouldn't think that C is a high-level language, would you? But it is when you compare it to assembly and machine code. So you compile to assembly, and C is a sort of a high-level general-purpose language. You can target different architectures, and it will compile to the assembly language. Isn't that amazing? I think that's amazing. I think that's really cool. I never really thought of C as a high level. I always thought C was low level, and it still is, but like you compare it, we're in assembly now. So it is a high level language to us, you guys. Let me see here. So I hope that answers your question on that. Pavel has a TrainSec platform I recommend to know everything about Windows, also assembly. Okay, so Pavel has a TrainSec platform. Cool. Good to know, Bull. Thank you. Shyam, hey Steven, how are you today? I'm doing good, thank you. We're walking through some things here, and we're reading through some of the chats really quick. Let's see here. Oh, okay. So Koroski and Creel have good tutorials for x64 programming. Good to know. Simone, thank you. That's actually really useful. Bytecode. Oh, bytecode. That's what it is. Bull. Yes, bytecode. That's what an intermediate. So you've got like Java down to bytecode. And same with like, I think Python does that. I think Golang might do that as well, but Golang actually compiles to a binary. It can go all the way to a binary. And then target your operating system. So would it be an agent that uses Google aggregated shopping search engine, or do something it uses with your own specific site? Let's find out, not Owen. Let's find out. Here's what we're going to find out. No, amazing. First time here. Hey, Ultra Hash. Ultra Hash. Your name is powerful. You've got this idea of hashing things, but ultra, right? So something like an MD5 or a SHA-1. There you go. Ultra Hash. Excellent. Hi, good to see you. First time here. Happy to have you in. We're currently going through agent payment protocol, which is AP2. Google just released this. Look, 13 hours ago, guys. 13 hours ago. And so we want to walk through it. And so that's what we're doing really quick. And then we're going to do assembly. And then we're going to do assembly. So first, we're going to do this right here. We're going to do agent protocol. Look at this. I noticed this, and I've been wanting to talk about this for like 10 minutes now. Here, check this out. Instructions. Look at this. All right, here. Just think about this for a second. Hold on. Check this out. This is a source code file. This is Python. It's meant to have source code in it. But look, you guys. Look at what I'm looking at here. You are a shopping agent responsible for helping us find users purchase products from merchants. Okay. So it's basically an agent that's being told that it's going to be shopping for someone. Look at this. This is what's crazy. Here's the crazy part. This code is, look how this, it's all like, look at this language. Isn't this crazy? Okay, here's why it's crazy. It's source code, but we're starting to see it happen more and more now where the code itself is just instructions to a large language model. So your source code files are going to be less code and more instructions. Isn't that look? It's happening already. You're looking at it right now on the screen. Look at this right here, you guys. This is crazy. This is crazy. Look at it. It's source code that's mostly instructions for the large language model. What? Are we already there? We're already there. We're in the future, you guys, right now. This is crazy. Look at this. Send this message separately to the user. This is where you would be redirected to a trusted surface to confirm the purchase. But this is a demo, so you can confirm your purchase here. Call the create payment mandate tool to create the payment mandate. So there's a tool. They've got a tool. Gmail user, right? I know, it's crazy. Drawing Brothers, hey, welcome in. Happy to have you here. We're looking at something. We're looking at the future right now. We made it to the future. This is a source code file, but the file is mostly instructions to an LLM agent. Isn't that crazy? Going forward in the future, this is the future programming. Look right here. They just told the AI to do all this. They told it to do all these things. Isn't it crazy? Instead of Python code. Thank you for the likes, you guys. Appreciate it. I know, it's amazing. Christopher Smith, this is just insane. I'm just going to find different skills, I guess. I know, right? It's a whole new skill. It's different. LOL, like one of my friends working says, time to learn farming. I know. Isn't that crazy? It's like, what's the point of programming anymore if the source code files are just going to be prompts? If the source code files are just going to be prompts, what's the point anymore? Why are we even learning assembly? Why? It's fun. Don't get me wrong. I think it's a lot of fun. Learning the code and assembly. Drawing Brothers, what is it? We're looking at the just released AP2 protocol that was built by Google. They just released it. It just came out. Like just 13 hours ago. Thanks for the likes, you guys. Appreciate it. I know, it's crazy. And so there's source code. Here's some Python code. We get sub-agents, payment method collector. So these are methods that the agent itself is going to be calling. So it's going to be calling these functions. And the code file is all just LLM instructions. Isn't this crazy? And look at these tools. Here are the tools that we're passing. So these are just instructions that tell the LLM how to communicate. isn't this? So here's also, if you didn't know, in previous streams, this part of the code right here is the most important part of the code for the rest of your lives. For the rest of your lives, right, what you're looking at here on the screen is the most important thing. The AI is able to communicate with you deterministically based on instructions that you give it with these tools. Thank you for the likes, you guys. Appreciate it. It's the tools. This is the future. Right here, you're looking at it. It's most important thing to learn, because if you've ever wondered if you use the Perplexity Comet browser, or if you've used any other kind of agent-based system that can drive your computer and click on things on the screen, it's using this right here to do it. You guys, it's using this technology right here to do it. Christopher Smith, even the Android code is like this. Let's find out. Let's look. Let's find out real quick. Let's check it. Let's take a look. So we've got our Python here, right? If we got our Python, let's go up one directory. There's an Android here. Let's see if it's the same. Shopping assistant. Here we go. So we got some Gradle, which is a bunch of build stuff. Let's go into the app probably. Is it the same as NPC? Drawing Brothers. Yeah, you got it. So NPC is sort of like a different approach, kind of. It's the same exact same thing. It still provides tools to the LLM in order to communicate deterministically with the code that you've got running. So it's just sort of like an inversion. So you can either submit tools to the LLM and then parse those tools, or you can use the MCP, which will then which requires an agent on top, or another program, or like a CLI, like Claude Code CLI, needs to operate that can connect and communicate with the LLM and your MPC server. So it's got this intermediary. But you're right, Drawing Brothers, you're 100% correct. It's exactly the same. It's totally the same. Isn't that crazy? All right, let's look at the source here. Let's look at main, probably. Main. Is this where Java? There's too much stuff, you guys. There's too much stuff. Agent. Here we go. Maybe this is it. Shopping tools. KT. Kotlin. All right, so we've got Kotlin here. Credentials. Agent. Cart mandate. Contact address. So there's a lot of stuff here. There's a lot of stuff that's going on. Things that are necessary. Shopping tools. So here's all of the shopping tools. Kind of interesting. Okay, so this is the tools we were talking about earlier. Find products, okay. Natural language description. So what we need to do is, add text, find products that match the user's intent mandate. Interesting. Ultra hash, okay. What do you got here? Welcome to Android's project. So many folders. I know, isn't it? Christopher, there's way too many folders. There's too much abstraction. We need to make it so it's simple and keep it. I know it's nice to have everything in folders and tidy and tucked away, but still, like, there's just too much abstraction. All this can be done in a single file. Ultra hash. So it has already have predefined functions individual with no dependencies, and using LLM agents to trigger this function. Yep. So the logic is being written in English. It is. You're totally right. Ultra hash. The logic is being written in English. So the AI is just using the code in order to provide deterministic input and output. So that way, instead of responding with just, a bunch of I found, it responds with a bunch of text, that describes it. It responds with JSON instead. So that way you can parse it and then work off of it. So you're totally right. The logic has been written in English. Isn't that crazy? Failed to parse search object. Okay, suspend cart. Okay, so this looks like just a bunch of instructions. Update the cart with the user's shopping address. What language is this? Right? Beauty. Okay, the language is Python, or well, I guess in this case it's Kotlin. So this is Kotlin, right? This is Kotlin language, but it's mostly English because the code is just a wrapper around a lot, like Ultra hash just pointed out, like the most critical aspect of this. The logic is written in English. Isn't that crazy? The logic is written in English, but most of the code we can see here. So I do see there is quite a bit of, I guess, just parsing. This is just interactions with the agents. That's all this is. Interacting with the agents. That's what we're seeing. That's the idea. Can you add first after GitHub in the URL? Wait, what do you mean? What? Can you add one S after GitHub in the URL bar. What is that? What does that mean? Like question mark 1S? Like that? It's like something like that. What does that do? I don't think that does anything. I don't know what that does. Interesting. I'm not sure. I'm not sure what that does. Let's see here. Let's see if there's any other. Let's see if there's any other code. Let's go data. Maybe is there anything in data? Shopping agent types. Okay. Kotlin X serialization. A bunch of abstraction. Cart mandate. Merchant authorization. Serial name. User cart confirmation. Payment request. Cart expiry. Merchant name. Okay. There's just a lot of abstraction here. I feel like this could have been simplified so much. Serializable. Okay. So this could be JSON. It makes sense. It makes sense. Okay. What else we got? What else we got? All right. I think I've kind of, I think we're, I think that's about it. I think that's about it. Oh, wait, Drawing Brothers. I have a question. Why do we use AI if we can do the things with traditional programming methods? Because because now I know you're totally right. There's so many scenarios where we could do it just with regular programming. Like there's no need to use AI. I think the idea is to stretch to see what's possible. How far can we get with the AI, existing AI, and seeing what it's capable of and what it can accomplish, even though it's completely wasteful. It's like a waste compute, you guys. Christopher Smith, I think he wants to take you to a specific user profile on GitHub with the 1S. Oh, gotcha. So github.com/1S. Okay, let's try it out. 1S. Here we go. 1S. That is, all right, let's see here. Minus. All right, so this is a profile. When did they join? 1S. Is it a very recent profile? It looks like it's a very recent, September 25. Oh, 1 second, you guys. 1 second. Hold on a second. I have to go real quick. I need to pause. Well, pause 1 second. There's a thing I have to do really quick. Okay, 9 days without rebooting. Just have mercy. I know, Victor. 9 days without rebooting. Right here, it's on the top of the screen. You can see 9 days without rebooting. Right here, 9 days. Right here at the top of the screen, 9 days. Yeah, and it's going to go longer. We're going to not reboot for a lot longer than 9 days because we're running Unix, you guys. We're running Unix. All right, 1 second. I hear the alarm going off. I have to go. I'll be right back. 1 second. Here we go. Let's see. Where is it? This button here. Nope, not wrong button. This one. Here we go. All right, I'll be right back. 1 second. BRB. All right, we're back. That didn't take long. It did not take long. All right, here we're back. All right, cool. So we just looked at, what did we do? We looked at this profile on GitHub. We did it, you guys. We did it. We looked at the profile. What is it for? There's a hello world. I'm actually kind of curious. Let's look at this hello world. Nope, just kidding. There's nothing in here. Christopher Smith, you don't need to reboot a Mac. Hello, reboot mine once every 2 months, maybe. Okay, yeah, cool. Yep, you got it. Yep. So, yeah, that's about it. Once every 2 months or so, and then like something will happen, and you'll need to reboot. Like either a patch, some sort of patch comes along, and it's like you have to reboot now. All right, hello world. There's nothing in there, you guys. This is a cool username though. 1S, 1S 1 second. Ironic. It is. I know. All right, what's in the host? See, I'm actually kind of scared because if we go into, we might see something we don't want to see here. Google hosts. 9 years ago. Wait, is this a fork or is this the original? It's not a fork. This is not a fork, right? This is not a fork. This is a legit repo. 11 years ago. Wait, what? Stay sharp. Oh wait, it is a fork. Oh, it is a fork. Okay, that's what's going on. But it was forked 9 years ago. All right, so here. So what is this? Hosts for Google services. I don't know what this is. It's a whole bunch of kanji, it looks like. Or is this Mandarin or kanji? I can't tell. Windows X. Yeah. I'm not going to proceed too much further from this. But here we go. I think so. That's hosts. What is this? Let's look at this real quick. Let's just take a look. I'm actually kind of curious. Mangular General EA. What is all this? Whoa. What? What are you doing? Why would you put? Okay, so this is your host file. So you've turned everything. You've turned every website to go to your local host. Is that what I'm seeing here? Oh, look, these are ads. Oh, check it out. These are ad service domain names. A double click. Look at that. Okay, so you know what you can do with this, you guys? You can copy this host file into your own host file and then turn off advertisements by doing it like this. Isn't that cool? This is neat. Oh, look at that. Oh, wait, WordPress. There's a Dropbox. WordPress. Interesting. I wonder, is pub. Nope, we're okay. Yeah. This is, what are you doing? Kane. Hey, Kane, Lakeway. Golfy. Go flow. Hey, can you please tell me what you're doing? Okay, yeah. So someone asked us to look at some source code, and we did, and we started looking at it, and then we got down this rabbit hole. But I think we're done looking at the source code now. We were looking at the agent-to-agent protocol, which is a payment protocol. It is an open source protocol for the emerging agent economy. It's designed to enable secure, reliable, interoperable agent commerce for developers, merchants, and the payment industry. So that's what we did. We just looked at the source code. We looked at some of the source code, and it was crazy. A lot of the source code was just plain English for the LLM. Isn't that amazing, you guys? That's so crazy. LOL, so funny. You check your own domain. I did. You did. You saw Christopher Smith. You saw that? You saw that? You're paying attention. Christopher, you saw that? Good job. I did check for, I checked for PubNub. I checked. You saw that. That was crazy. Can you please explain what's happening? Okay. We looked at the agent-to-agent protocol, and then Ashutosh. Hey, how's it going? Yes, you did. Good job. Yeah, thank you for you have to be paying attention to see, because I had it on there for less than a second. It was up there for less than a second. We just walked through the AP2 protocol. And so if you missed that part of the stream, it's recorded, so you can check it out later. But we're going to go now into our assembly. We're going over to assembly. So this is day 5. Let's see here. Oh, I did a thing. Here we go. Let's move that assembly back up here. Assembly day 5 is what we're doing. There we go. Assembly day 5 is up. All right, looking good. Here we go, you guys. All right. So what we're going to do now is we are going to read through and learn more assembly. We're going to learn a bit more of the assembly here. So let's close that. Now we're good. Now we're looking good, you guys. All right, now we're on the assembly here. We want to learn how to convert a number to a string. Here's the deal. It is computationally a lot of operations. Look at this file right here. There's 50 lines of assembly just to convert a number into a string. Isn't that I think it's unacceptable. I think there needs to be a more efficient approach to converting a number to a string. But what it requires basically you have to iterate through the number of digits. You basically have to iterate through the number of digits. So if you have this number of digits, you have to iterate through each of them. So every time you have to create a divisor. So you have to 1, 2, 3, 4, 5, right? And then you have to keep chipping away at it until you get all of the digits down to every single digit consumed, basically. That's the idea. And so once you've done that, then you've essentially taken all the positions of the characters and converting each of the characters in the number into a string. And that's exactly what this assembly code does. It's actually kind of neat. So I know in other languages, you only need like a few characters, right? Like a two-string method. And that's what this is doing. It's doing this stuff here. So let's check it out. So remember that this is subtracting 1. So we're decrementing this particular register by itself and reassigning it to itself. Move says, and I didn't know you could do this. Check this out. Is this right here? Is that a string literal? What is this? Let me see if it is ASCII 0. You can do that in assembly? I had no idea you could do that in assembly. I had no idea you could do that. Like, I really didn't. Can it go, can you do a string? Can it be a string? Can you do something like, so obviously it can be like that. So I can turn it to a 1 if I wanted. I'm actually kind of curious. Okay. So let's see if our application builds. Let's try to build it real quick. Let's see if we can build. Okay, it builds. All right, let's run it. What we're going to do now is we're going to run it. And then I think this is main. Here we go. So, oh, it's seg faulted. It's seg faulted. We have to go fix it. And look where it's seg faulted. It's seg faulted on the part exactly where we convert the number to string. Like, isn't that crazy? Right here, we convert the number to a string. Shimon, okay, you can store a number directly in decimal. You can use every 4 bits to represent 0 through 9 instead of 0 through 15. Oh, then you don't need to convert, but you have to adjust results of each math operation. That is a really good idea. That sounds far more efficient. That sounds far more efficient than what we're currently doing. It is used in some calculators for simplicity and precise divide by 10 division, but on modern computers, just converting into string is fine. Okay, gotcha, yeah. That totally makes sense. So let's see if we can fix that. I think this was because of that. I think because we hid that. We commented that out. All right, let's see if we can build it and run it again. Okay, so we build and we run. Okay, there it goes. Okay, we're good now. We're good. Okay, it's running. It's running, you guys. So we're actually converting it. So what we did here, let's actually go through main really quick. Let's run through main. Emain.s. Here we go. So what we have here is a counter that starts at 0 and it increments. We increment the counter. So we take the counter and we page. We need to figure out what this is. I'm not. We're running. We're jumping ahead here. But we increment the counter like this. Add x5 register 5 to itself, which is 1. This number 1 is a literal number 1, and it says basically counter plus plus. I get this part. That part makes sense because I know C. Hey, quantified. Welcome in. Happy to have you here. We're just getting into the assembly part of the stream. We're learning how to increment a counter, which is a little bit. It's not as involved as converting a number to a string, but it is. There is some to it. There is a little bit to it. So ADPR. We're going to add, so we're going to update some addresses and offsets here. That's as far as I understand that. Some addresses and offsets. We're going to load x5 equals the counter, and then x4. Okay, so now x5 is going to be the value of the counter. Is that what we're looking at? I think that's what that is. And so then we're going to increment x5, and then we're going to str. Wait, what is this? x5 to 4. What's this right here? What is str? What is that? Str is store register x5 to address in x4. Okay, so that's what's happening there. Interesting. So when we have these brackets, cut out, here we go. We are learning Intel 32 assembly, and our teacher said there's no data type in assembly. Actually, it's just how much space you want to give the data. Right. Data. Okay, so DB, DW, DD, DQ, DT, 1, 2, 4, 8, 10, respectively. Yeah, that makes sense. Steven, I want your opinion on generative UI, which you were talking about. I remember, Xiam, you were talking about this the other day. Load register. Okay, LDR is load register. Got it. And I'm actually curious, do you always need the brackets in this scenario, and does the brackets have meanings? I'm actually kind of curious about that. So cut out, you're learning Intel 32 assembly. That makes sense. That's actually a pretty good common assembly to learn because it's simple, but also you get some of the advanced instructions. So very nice. We're learning ARM64 assembly. We got some answers from Shimon here. Simone, STR store register, STP store pair of registers. Store pair of registers. LDP load pair of registers. Okay, we're getting more details here. A few more details. Okay, so this STR store register, which to me I think this is like string, right? STR is string. And that's why I was confused. I'm like, oh, that's definitely got to be a string. But no, it's not. It's store register. STP, store pair of register. And then LDP, load pair of register. Okay. What's LDR then? Just load register, like regular register. So it's not a pair, but regular. What are we doing ARM now? Yeah, we're doing ARM. So this is ARM 64. But it's, for the most part, the language, the different assemblies are going to be the same with a few minor adjustments here and there. Nushad, hey, hello, Steven. You always grinding, man. Yep, we're doing it. We're learning some more assembly today. That's the plan. We're making it happen, you guys. Brackets are for dereferencing addresses and registers, so they need to be used with every memory operation. Oh, no way. Okay, so Shimon, thank you. You are the teacher. You're teaching. We are learning assembly because you were here. Thank you. So many streams. You've been here and you've been teaching us. This is amazing. Thank you so much. So the brackets here, the braces or the brackets, they're for dereferencing. So X4 is the register and then the address of X4, and then essentially assign X5 to the address of X4. And then I get that. Okay, so we're starting to get it. We're getting it a little bit. Things are happening, you guys. We're making things happen. Okay. Quantified quantum. Dang, I'm going to catch up on assembly tonight. Screw Next.js. Screw database stack redactor or refactor. Exactly, yeah. Assembly is a lot of fun. It's teaching us a lot of things here. Some of the things that I thought were pretty novel, like for example, like in C or even in Python or JavaScript, things that I thought were novel and innovative in those languages, or just already done in assembly. They're just borrowing ideas from assembly. I was really surprised. Like I was not expecting things like that. Like very simple things like this, like defining variables. Like I thought that was novel for a high level language to be able to do that. I thought that was novel, but it turns out assembly is already like that. The name of the variable right here, right? The name of the variable, the type of the variable is here, right? So the string, and then the literal data of the string right here. Isn't that amazing? I thought that was crazy. I thought that was innovative in the high level language. But guess what? Assembly, it beat you to it. It's first. It's number one. Yeah, see, it's just sugarcoating on assembly. It basically is. Yeah, it's sugarcoating on assembly. Jack Keeble, hey, you're learning. Excellent. Here, learning. Great to have you here. Excellent. Absolutely. We're making things happen, you guys. We're figuring it out. And it's actually kind of exciting because you can even create structs. You can create structures in assembly as well, with which it's like multi-factored variables. Did you know you could do that? Like I didn't realize it was before. Let's see. Jack Keeble, and I'm your beer leading the MERN stack. And this guy learning assembly. Fair play, brother. Yep. There you go. I mean, you got to learn. You always got to learn somewhere. And guess what? I've been doing this computer technology stuff for a while now, and I'm only just learning assembly just now, and I still don't get it. I'm only getting just a little bit of it. Like we're figuring things out. We're learning it as we go, you guys. It's so cool. I love it. Cut out. Why are you learning assembly, if I may ask? It's for fun. For fun, right here at the top of the screen. For fun, you guys. Have fun. We're learning for fun. So we did the system call. We accomplished this. So let's say check mark, right? Check mark. We did that one, and now we're currently on this one right here. So this is like not a check mark, but a incomplete. What is it called? Let's do that. Let's do like a hourglass or something. Yeah, let's do an hourglass. So we're currently doing that, and we're always having fun. So we'll do smiley sunglasses. Here we go. Smiley guy with sunglasses. Always have fun. Here we go. Here we go. Fun, fun, fun. That's the idea, you guys. Why assembly? Because not only is it entertaining and is it fun, and it's really satisfying. Like it's really satisfying when we figure stuff out. But it's foundational. You learn a lot by learning assembly. You didn't realize that a lot of programming languages were just borrowing from assembly. Thank you for the likes, you guys. Appreciate it. I like to see those icons floating up on the screen. The quantified quantum. Oh, by the way, have you tried CTOP? C-top. It's like H-top, but C-top. It's like H-top, but an upgrade? Is it? Really? Okay. Brew install C-top. We're going to try out C-top for the first time ever. Is it really? You can do C-top? Look, guys. No. Okay. C-top. Let's check it out. Thank you for the likes. You guys appreciate it. What's C-top? C-top error. Attempting to reconnect. Okay, it's only works on Linux. It looks like only works on Linux. It's looking for things that it does not have. All right, we can't do C-top, you guys. C-top does look like a no-go for us. No-go for C-top, but we can do H-top. H-top. Here we go. H-top. All right, got H-top back. I tried C-top. Unfortunately, it did not work. But I was really excited. You got me really excited. Let's see here. ARM is so clean and readable. Very opposite to MIPS instruction set that are black magic. Is it really? ARMS is sort of I think it's great. I think it's a great I'm just telling you what my feeling is without actually having much knowledge about it other than I'm enjoying it. That's what I can tell you. Do we have Python for ML projects? Downtown, do we have Python for ML projects? We do. This will be happening. We will be doing this again in future streams. We will be doing more ML, machine learning, and artificial intelligence because it is a hard and challenging and a lot of fun. We want to do the hard things here. That's what we're doing. That's the plan. And we're doing assembly because it's hard. Assembly is hard. Joshua, is this a GD plugin for Vim? A GNU debugger plugin for Vim? I don't think so. Is it? Oh, is that what C-top is? Actually, I'm kind of curious. I don't know. I actually don't know. Oh, Joshua redacted your message. Never mind. Too late. I already read it. I saw it before you deleted it. Okay. It's too late. You tried, Joshua. You tried to delete it, but I already got it. All right, let's see. I'm going to catch up with some of the chats here. I'm going to buy a Mac M4 Air. Confused between 256 and 512. Should I spend extra? Yes. At least spend the extra 200 because that's double. And I always run out of space. I usually get up to 512. So I recommend at least getting 512. That's a good idea. At least get 512. Bull, in my opinion, this is the exact opposite. MIPS has way less complex instructions. Okay. Shimon, I was wondering because ARM64, it seems like there's quite a few instructions. Just quite a few instructions. And especially, we do not know hardly any of them yet. You meant B-top? You meant B-top, Kane Lakeway? Okay, let's try B-top. Let's try B-top really quick. All right. Brew install B-top while we read more comments, you guys. Oh, wait. Brew install B-top. Spell it correctly. All right. Quantum Quantified, rest in peace. Joshua, what are you using for debugging? We're not. We're using print. We're using print for debugging. I suppose we could use something, but we're not. All right, B-top. Let's try this out. B-top. Here we go. Need for the current config. 80. Perfect. Okay. Yes. Terminal size too small. Is it? Oh, it needs more height. Okay. We'll give it. It needs 24. All right. Fine. All right. Resize. We'll resize it. Resize to 24. Is it good enough? All right. Boom. 24. It didn't. Hold on. Oh, I named the windows. All right. B-top. All right. Resize 24. Bam. There we go. 23. Where? All right. Fine. Resize 25. Boom. All right. There we go. Whoa. Check this out, you guys. Oh, you can see everything that's happening here now. Look at that. B-top is pretty cool. It's pretty cool. Look at that. Look at what we're looking at. It's kind of interesting. Let me get back while we got this looking on the screen here. We'll take a peek. Let me search it. All right. Maybe B-top IDK. It is B-top. B-top is really cool looking. Look at that. Quantified quantum. I mean, for readability, you think, Shimon, you think that the older CPUs are the best because they were made with ASM programmer in mind. That's right, Shimon. So like back in the day, older CPUs were intended to be programmed with assembly. And so assembly back then needed to be readable by humans and maintainable by humans. So 68,000, the Motorola 68,000 or the old Intel, Z80s and 6502s. I remember 6502s. I remember those. Yeah, so they were better for ASM programming because they were simpler. Oh, it's B-top. It is not C-top. I know. What about D-top, right? Is there like a H, like an L-top or an M-top? There's going to be all sorts of tops, I bet. Joshua, yep. Lamau. Jake Keeble, you're bringing the energy, man. Keep it up, making me want to learn assembly now. I know, it's so cool. I love assembly. It's a lot of fun. We're enjoying it a lot because it's very satisfying, especially when you figure things out, because you've been programming in other languages before and you realize assembly is really just the majority of the work is actually represented in assembly, and it's kind of fun to figure it out. It's really fun. Enable colors. B-top looks better with colors. How do we do that? How do we enable colors? I don't know. Question mark. Delete. Oh, what's happening here? How do we do it? Show options. F2. Let's do F2. F2. Oh, O. 0. I'm trying to press buttons. None of it's working. Nothing's working. Options. Help. Quit. Help. Options. All right. Options. Here we go. Ooh, theme. Default. Ooh, it gets pretty. Groovebox. I want Groovebox. Theme. True. Color. False. True color. False. Okay. Groovebox. Here we go. Look at that, you guys. Whoa, it's getting fancy. Look at B-top. It's beautiful. A-top. Yeah, let's do A-top. Thoughts on NeoVim. Ken Lakeway. Lackway. NeoVim is an excellent release of Vim, but with Lua on top, right? It's got some extra built-in, some extra plugins. NeoVim is fantastic. I like using regular Vim because it's installed on most systems by default, including when I SSH into servers. And then I get to have a similar environment no matter where I go. And that's and so if I was only using one computer the whole time, I might just choose specifically NeoVim. But in this case, I'm just doing regular Vim. Just regular Vim. B-top looks way better with colors. Look at all the different colors, you guys. This is cool. Illuminati bot. Yo, bro, what's up, man? Good to see you. Illuminati bot. We are doing some assembly, but we got distracted by the pretty colors of B-top. That's cool. Look at this. Look at all these colors. I can't figure out I think Groovebox would definitely be my favorite because Groovebox is my go-to. But it looks like it's just it's a red color. That's all it looks like is red. It just looks red. This is kind of nice, but kind of hurts the eyes. This is pretty. One dark. In the white. Calyx. Dusk is pretty cool. Adapt. Here we go. Adapt looks great. I like Adapt. Here we go. Groovebox Material Dark. This is what I like. I like this one. This is my favorite right here, you guys. Go try D-top. Yeah, I know. We're going to have to try all the different tops, aren't we? Quantified Quantum. Bull. Okay, so you learned assembly reading the RE4 book, Resident Evil 4 book, or what is RE4? For me, MIPS is so hard to read on the first glance. Also have caveats such as executing single instructions just after a branch makes it harder. Got it. Interesting. Okay. We figured out what branches are. We're figuring out. Illuminati bot, do you recognize me, man? Illuminati bot, yes, I remember you weren't in the past few streams, but you were in some previous streams. I do remember Illuminati bot because your name is catching and memorable. Christopher Smith, it's pretty amazing how you code in this. LOL, you'd be lost without a JetBrains IDE. And yeah, you get used to it after a while for sure. So B-top was cool. I liked B-top, but it takes over most of my screen. So we'll have to stick with H-top for now. We'll have to stick with H-top. So let's get out of there. Resize. We're going to resize this back to, resize it back to, I think maybe 15. There we go. And then we'll go back to our H-top here. There we go. All right, now getting back to assembly, and then we'll here's the goal. We have to get through today number to string conversion. We have to. That is absolutely important that we do it today because we've been doing it too many days. Do you want assembly challenges? Kane Lakeway. That would be a lot of fun. I would like to do some assembly challenges after we learn assembly. I think that would be a lot of fun. Right now, I don't hardly know assembly at all. We're just figuring it out. Like these different moves, like different level of moves, like assigning data based on the current bit I guess, Indianness or the focus of where the bits are in a 64-bit, like 32, 64, the 16, and then 32. Like, and there must be a different move K or move MOV. There's got to be a different MOV, right? I know there's got to be a different move. There's different kinds of moves. Try GTOP. Maybe it will solve the size problem. All right, this is the last. We'll try. Okay, Quantum High Quantum, you're totally right. We'll try it. All right, let's go to 4. We'll call this GTOP. You call it GTOP. Okay, brew install GTOP. All right, let's see if it works, you guys. We're gonna try it. We're gonna try GTOP. Let's see here. Open source applications. Now I made different kind of content. Don't ask me what. It's me, man. Oh, is it? Okay, Illuminati bot. Then yeah, you changed your name. Is that what you did? It's me, open source applications. Now I made a different type of content. Don't ask me what it is. Okay, Illuminati bot. Okay, open source applications, everyone, is Illuminati bot. We figured it out. Reverse engineering for beginners, RE4B. Also, that MIPS features named branch delay slot, I think. Okay, gotcha. Let's try out GTOP, you guys. GTOP. Here we go. GTOP is loading. It's trying. Nope, it crashed. It failed. Error. Didn't work. Oh, it uses Node.js? What's going on here? Why would a utility? Thank you for the likes, you guys. Appreciate it. Why would a utility use Node.js? That's a little bit overkill. There's a little bit overkill there, guys. A little bit. It's probably because I'm using Node version is a new version. It's a newer version. Thank you for the likes, you guys. Appreciate it. I can see the little floaty icons showing up there on the screen. It's so cool. I can see it. Here you go. You can see those floating icons. You see them right up there, right? That's what I see. When you do those, when you click the like button, I see the floating animated icons. It's so cool. It uses Node.js, explanation question mark. I know, right? Isn't that crazy? It's unexpected. It's absolutely unexpected. It's weird. Let's see here. It's only because of the most classic version of MIPS manual hazard handling. Thank you for the likes, you guys. Appreciate it. I can see those likes floating around there. Next to the chat messages is terrible, but modern MIPS removed it. Oh, did they? There's a 64-bit MIPS now? There is? Oh, no way. Didn't realize. Drawing Brothers, how do I contribute to your first open source project? You just go in and add code comments. Drawing Brothers. So here you go. Watch this. You go over here. You grab one of these repositories, like this one, for example. And then see, look how there's no code comments here. See how it's missing code comments? Like, there's so many places where you can just add code comments and commit the code comments and make that your contribution to the open. And they're pretty, like, benign. And so they're easy to, and when you make your pull request and you make code comments, they're like, sure, why not? Like, and you have to be, make your code comments nice and good, concise, clean. But, they're easy to merge because they don't do anything. They don't change the application at all, but they tidy the application. And then you just say, hey, I wanted to tidy this because I'm working with this code base. And so then you contributed to open source. Isn't that cool? Back to HTOP. Yep, you got it. I like JTOP. Eros, JTOP. All right, here, we're going to try JTOP. Brew install JTOP. Is that even a thing? We're going to try it real quick because Chad is asking about it. It is not okay. Eros, it doesn't exist. There is no JTOP, or it is exist, and it's just not in Brew. It just doesn't exist in Brew. All right, let's get back here. All right, we have a goal, you guys. What are you going to top? We're going to the top rabbit hole. I know. We got distracted by fun, shiny things is what we did because it's fun to watch. It's like benchmarking your system. You're able to see what the resources are being used. It's really cool. Okay, so let's make sure we are building and we are running. Okay, so we're building and running. That looks good. So what I want to do is go over here and then add a space in front of this so I can better see. So let's do ./build, and if it's successful, then we run main. Let's do that. There we go. Successful main. Okay, cool. So now you can see that we're incrementing a number, and we're printing the strings so number to string conversion is working, you guys. Let's code, man. Let the man code. I know, exactly. Have you ever had Wait, Kathleen, what do you mean? Why do you have HTOP? I have it up there because it lets me know if something runs away. Like it lets me know if like extra compute is occurring where I don't want it to. It's nice to see. I like to see it. But yeah, so we see here our number conversion's working. Our hello world is working. And let's just see if we can walk through the rest of the code and kind of see. Now we need a \n. Okay, let's do it. We'll add a \n, you guys. Let's do it. All right, so I think we can do \n right here, like that. All right, here we go. Boom, adding \n. There you go. Now we added a \n, you guys. That's how it works. There we go. Now it's a little bit more readable. Now you can see what's happening a little bit easily. Or if it's a memory leak, it helps. Okay, gotcha. Yeah. How do you understand a project quickly? It looks like, so Drawing Brothers, let's see what you're saying here. It looks like a forest at first glance. It always does. It always does. It always is, you guys. It always is a forest. And so it's just about reading through it. Find the main entry point to the application and then kind of run. Are you using Tmux? This is GNU screen. So this uses screen. So screen dash version. We're using screen version 5.1 right here, you guys. Screen version 5.1. Screen version 5.1. 5.1. This is version screen is what we're using. Not Tmux. I like Tmux. It's fine. Just a question. Quantified. Just a question. 49 gigs of RAM usage. AI model running in the background, maybe. It's Chrome tabs. It's a bunch of Chrome tabs. Quantified quantum. It's a bunch of Chrome tabs. Hey, Kane, likewise, you said hi. Hey, thank you. You've been hanging out here in the stream for a while. Always happy to hear you say hello. Definitely. IAM, Identity Access Manager. Hey, how's it going? Linux or Windows? Linux. It's Mac. So Unix variant. Thank you for the likes, you guys. Appreciate it. I can see those little floaty icons show there up on the screen. Okay. Holy, how many tabs? A lot. A lot of tabs. And I also organize my Chrome tabs with like those tab organizers. So like I create those tab organizers. So this isn't my main Chrome window. My main Chrome window is somewhere different. You're not seeing, but I always like organize my tabs. Like I say group into a tab and like group into a new tab. And they go da-da-da-da. Like crew that into a tab like that. There you go. Drawing Brothers Mac. Yeah. A lot of tabs I got open. All right, let's get back to coding here. We have to get through. We're almost through it. So let's see if we can learn a little bit more. Okay, here we go. So we've got a counter. We've got the address that we're I guess, so X4 is going to be the beginning of the counter based on the page size, I guess. Is that what's going on? And then we're adding X4 with X4 address, I believe here. Those tab groups are a blessing. They are. They're so worthwhile. It's really great because, and even Chrome now will try to optimize its use, but it knows that I have a lot of memory available to me. So it's not like unwinding some of the tabs. Like it'll unload tabs that are not used and it will save memory. But it knows that I have enough memory. So that's why there's 49 gigs of it. I'm going to make an AI tab organizer someday. Good idea. That's a good one. I actually have one. I have a specific one for AI. Okay, so dereference, we recognize that the brackets are for dereferencing, and then we're incrementing by 1. And then so X5 is going to be our increment, and then we're storing that back in store X4. STR is to store register 5 to the address in X4. And then we've got a counter, so we're incrementing here based on a buff. So this is weird. So this is the part I don't get. This is the part I do not understand. Well, actually, okay. So here's our counter. So we're maintaining our counter here. This is where we're maintaining our counter. Dang cool, isn't it? JTOP, Eros. All right, we'll try it one more time. Well, didn't we try it? Brew install JTOP. Is that even? Did we already try that? Didn't we? We didn't. We tried JTOP. It doesn't exist. It's not there. It's not a thing. Okay, here we go. Okay, so this is for incrementing and storing the counter. This is for preparing the counter and to converting it into a string. Here we go. And so we've got this U64 to string right here, which is taking X0 and copying it, value to convert, so x5. So x0 is going to be the argument that U64 is going to use. So if we open up the U64, I think it's called U64. There we go. Let's move that over here. This is our function. And so here we're taking 4. Okay, 4, and so we're grabbing x0. So 4 is going to be x0. Then I don't know what's going on with this. I really don't get this part. I also, previously we were getting help from Shimon on understanding the stack necessity for this, but without this, it seg faults. So we tried to use it. We tried, but it seg faults, you guys. It seg faults. So we're converting to a string. Let's see if we can get through this. And then B2, I found out B2, the F is for forward. Go to label 2, which means that we're done. So this is it. We're done. So this is the done point. Okay, Drawing Brothers, I'm familiar with Python, JavaScript, Java, etc. I want to rewrite your desktop app using Rust. Ooh, that's a good one. Rust is fantastic. It currently uses Electron. Okay, so you could do that. Rust would be great. Use Tauri. It's called Tauri. You've already been here, Drawing Brothers. You've always been here, but Tauri, Rust. This is it. Use Tauri, and this will get you, I think, the next step. It's like one level above Electron. It makes it better and faster. All right, Shimon, it's really bad code, ? Looks like either it's written by A or it got from a compiler in debugger mode. Yeah, exactly. So it's gotten from a compiler. So you have enough registers. You shouldn't store a counter in memory. Ah, got it. Okay. So that's what's going on. So we're not learning from the best example in this case. We are learning, and we are making it difficult. We're making it difficult for us because the code is just a little bit too much. You're totally right. So thank you, Simone. Thank you, because I was concerned that the code was overly involved and complex. I was like, hey, it seems like to me this could be simpler. It seems like it could be simpler. And you just confirmed it. So thank you. I appreciate it. Isn't JTOP for monitoring NVIDIA devices? Is it? I use NVTOP. So when I'm monitoring NVTOP is what you want for NVIDIA. Use NVTOP. So if you're an AI developer or a software engineer that's using CUDA, NVTOP. You want to use NVTOP. There you go. Oh, by the way, have you heard of Rust crates, Node.js, NPM registry? Email scams. Yeah, I heard about the Node.js NPM ones, but not about the Rust crate. Are they infiltrating Rust already? Well, see, Rust has extra checks. So they've got, I guess there's audit trail. There's an audit crate. I forgot what it's called, but it's used to audit packages for security vulnerabilities. And so I'm sure NPM has the same thing as well. But of course, you have to have them registered. The crates themselves have to be registered in the database. But quickly, Drawing Brothers, but quickly what? Wait, did I miss a previous message? Yes, Electron, but quickly. I think maybe. Cut out. Hey, just for clarification, once again, you are converting an integer to a string. Yes, that's what we're doing, right? Do you mean 4,899, which takes 4 bytes, you want to convert to a string? Yes, 4899. What are you doing? I know. It's kind of crazy. So the way here's how the code works. I figured it out. What it's doing is it's capturing all the digits. So it's capturing all the digits to it's like sort of taking them away. It's doing, I think it's dividing by 10. So it's eating off all of the digits until it gets down to the last digit. So I think that's what it's doing. That's basically what it's doing. And then it goes 1, and then there's no digits left at that point. So that's what's happening here, you guys. That's what this algorithm does. It just it divides by 10 essentially. Yeah, or subtracts, or it divides by 10. It removes the 0, and then it just pops off. It pops, and it sees what the value is, and it just continues to pop there. Add zeros, and the code is 10 times faster. Yeah, exactly. There you go. That's how. O-S. The optimization flag. Okay, Shimon, understood. -O for optimization. dash OS for faster. Make it go fast. Make faster. Then O2. Yep, there you go. Add OS. And it's 10 times smaller. There you go. 10 times smaller. That's what it is. How can I get comfortable with Rust as I'm with other languages that I know? Drawing Brothers, it's really about practicing. So start a project and then have an end goal for Rust. So Towery is a really good idea. Make a simple desktop app with Towery and then see how it goes. I think that's a good project. Or, a simple hello world, or just getting started, or just trying to get used to the language just by building a project. And that's what we're doing here. That's how we're learning assembly. We have very specific, they're tiny tasks. They're very tiny tasks. Convert a number to a string. Isn't that a super small task? I think it's really small. And that's how we're learning. That's how we're learning assembly. That's it, you guys. NPM is so easy to publish packages. It really is. It really is. I'm a varnish, or you're going to vanish for 3 minutes. Okay. We'll see you in a bit. Quantum. JTOP is really only for NVIDIA Jetson platforms. Oh, but if you're running that platform, it's amazing. Is it? Okay. That's cool to know. Blue. Hey, Blue. How's it going? I don't understand everything that's happening, but just being here is so fruitful, and I've learned so much ever since I found you. Thank you, man. Thank you. Blue, thank you. Appreciate it. Coder Assemble. There you go. Don to Don. Don to Don. Is that like a play on Dan to Dan, the anime? I've been watching Dan to Dan, and it's really great. It's a great show. I want it to all be out now, but like they're releasing only a few episodes at a time. Wah! All right, here we go, you guys. Let's go. Let's see if we can see. So here's the divide. Here's the division. This is that we just saw. Thank you for the likes, you guys. Appreciate it. There we go. Yep, I love to see that. We've got the U division, and then we've got M sub, which is, I don't know what the M is for, but we've got 4 registers all at once. Why is it 4 registers all at once? I don't know. Which watch anime? Yeah, I do. Quantified Quantum, like watching anime. I'm watching Dan to Dan right now. Dan to Dan. I like it. It's a great show. Back, by the way. Yep, excellent. Welcome back. And we're almost through this. Okay, so are we nearing the end? So we kind of understand it. We kind of see what's going on. Sub, which is definitely subtract. Add is going to add 0. Oh, right. We're going to add a 0. And then we're going to store something with a B, and the W, which is the 32-bit register, number 8. Don. If I'm not mistaken, there had been a person who made a game using only assembly language. Yeah, there's more than one. Don. There's more than one person who's used. The one you're thinking of that was mentioned previously in stream is called Roller Coaster Tycoon. I heard someone mention that Roller Coaster Tycoon was written entirely in assembly. Roller Coaster Tycoon, written in assembly. The game was developed in a small village near Dunblane over the course of 2 years. Sawyer wrote 99% of the code of Roller Coaster Tycoon in x86 assembly language for the Microsoft macro assembler. The remaining 1% is written in C. Isn't that crazy? This game was written in assembly. Look at that. Look, how are you supposed to even know? It's too much. It's too much. It's crazy. How was it? It's amazing. And it's too much. That's why we need these higher level languages, so we can achieve more quickly, more easily. Don. How? I know, right? Isn't it crazy? Exactly the right sentiment. You've got the right question. Don. That's the right question. Drawing Brothers, when we write first arithmetic logic using ASM, that's so cool, but it was simple. Yeah, the first one is simple. We're kind of jumping into the deep end here. Like, I don't know what most of this stuff is. Like, I get move is to sort. I guess X4 is now going to be X7, and then conditionally branch X4 if it's 0, go to 0, which means loop. So this means loop. So this is our loop here. This is our loop. This looks like the loop here. And then and then there's an exit. Compute the length and return. So we get the length of the pointer, and then x3, and then x1 equals end, and the length is going to be x1, I guess. Is that what that says? Is the length of the x1? And then we return. I guess this is what it is. What is ret? Ret means return. Go back. Oh, so when we branch, you guys, when we branch, this tells it to go back to the branch. We're learning new things every day. Okay. The game is still great, isn't it? It's amazing. In sub. Okay. Thank you, Shimon. Thank you. Yeah, exactly. Quantified quantum. Good luck porting that game to ARM. It's not going to happen. It's not. It's just not. They're not going to make it happen. Yes, correct. I said that in the first stream. It's amazing, isn't it? Yeah, this is kind of crazy. Yeah, the roller coaster tycoon, maybe completely another game. It really is. It's just amazing that they were able. It's so hard to even tell what's going on in the assembly. You guys, it's crazy. All right, so Shimon, here we go. MSub, where's it? Where's MSub? All right, so MSub, here we go. MSub. Look at those registers, you guys. 4 registers on one line with MSub. MSub is some weird combined multiply and subtract in one instruction. That's the ARM complexity you were talking about. Look at that. Isn't that cool? So x times 10, the remainder. X equals value minus x7 times 10. It's crazy. That returns from a function. Yeah, we figured that one out. Returns, basically. So here we go. Check this out. Main.s. Here we go. So where we branch here, where is it? Here we go. So BL, we're branching. I forgot what the L stands for, but branching, I guess, to a function. And then that returns back to here. So this is where the return goes. You see the return here goes back to here. We figured it out. Okay. It's great. You'll subscribe. Done. Cool. Thank you. Appreciate it. Welcome as a new subscriber. We will be doing a lot of learning code, and we're going to be doing it the hard stuff. We're doing learning hard code. Assembly, we'll be doing AI. AI is very challenging. There's a lot of algorithms that are very difficult to use there. And then we'll be doing other things. Well, encryption, cryptography. We'll also be going through cryptography, like legit cryptography. What does it mean? What does it look like? How does it work? What does it mean factorizing? What the modulus? What is the modulus? Why is there a modulus involved in cryptography? What does the XOR operator do? Can we build our own cryptography using the XOR operator in a way that looks kind of neat? Or is it only for hashing? Right? There's a whole bunch of things. Quantified quantum, you're going to set up an ARM environment on your x86 system? You totally could. I think you can emulate those instructions. You can do it. It totally works. Dota or Dado. Hey, Dado. Welcome in. Happy to have you here. Our programming on CPU, have you tried learning ASM with CPU architecture that will make sense? Yeah. That's basically, so there are far more simple assembly language variants out there, and using a microcontroller of some sort, like a microprocessor, and just using simple assembly is probably way better. Thank you for the likes, you guys. Appreciate it. Don AI using assembly, that would be the ultimate hard mode. So we did do a very hard mode stream previously by building a deep learning AI machine model in Rust. So here's, of all my experiences over the years, over the decades, the most challenging thing. Thank you for the likes, you guys. Appreciate it. I like to see those like little heart icons show up on the screen. You can see them. You can see them floating up there. Of all the years, over all the years, AI and Rust have been the most challenging by far. AI definitely brings it up there to the top. But then if we go a step further and we combine the two, Rust and AI, that's what we did in some previous streams. We can do it again. We probably should. Yeah, exactly. Thank you for your likes, you guys. Appreciate it. And so we'll be doing more hard mode stuff like that. Maybe even doing some game development, because game development is hard. One of the most challenging. Thank you for the like. Well, look at all the likes. I appreciate it. I appreciate the likes, you guys. We're going to do the hard mode stuff. I think I'm enjoying it. We're at that point now. Why not? Why not do the hard mode stuff? I think it makes the sense to do it right now. But AI can help us along the way. And so we'll be doing that as well. Thank you for the likes, you guys. I appreciate it. such as an address bus, but how CPU access memory addresses? I don't know. I actually don't know. But Don AI using assembly, the ultimate hard mode. You cannot get harder than that. That was actually one of my, thank you for the likes. You guys see all those like hearts icons? You can kind of see them barely right here, like right there on the screen. I can see those. It would be, one of my goals, Don, was to use assembly to create a neural network. But you know what? Just looking at how hard it is to increment a damn number, it is a challenge to even consider doing AI in assembly. I mean, we could, but it's going to be really hard. I appreciate all the likes, you guys. Check it out. It's really great to see that. And here we go. All right. So wait, let me catch up with chat real quick, and then we have to wrap up stream. We're gonna catch up on some of the chats we missed. We're gonna wrap up stream. We're gonna finish walking through the rest of this code here. We basically got through most of it, but I want to kind of wrap it up a little bit. And then we'll have to wrap up stream, and then we are ready to go. Oh, and if before we end, we do have a Discord. So let's see if we can get that. We'll get the join link here. If you we'll go live at different times in the day, so it's not always the same. But join the Discord. The link is in there. Join the Discord right there, and we will be live at various times during the week. So it's 5 days a week, but usually between 10 a.m. and 2 p.m. Pacific. That's usually when we go live. Every weekday is the plan. And we'll be doing more Rust. We'll be doing more AI. We'll be doing more assembly. We'll maybe doing some game development. We'll be doing some cryptography. We'll do encryption. Basically, the hardest things that you can do in computer science. I feel like it's time, after so many years, that we get that going. So that's the idea. We're there. We're there for it, you guys. Okay, so let's wrap this up. Let me catch up with some of the chats real quick. Then we'll finish up the assembly code, and then we have to end. We'll be ending for the day. Rather than using a modulo instruction, this code gets the remainder using multiplication as subtraction. Simone, I didn't know there's a modulo. There's a modulo. Thank you for the likes, you guys. There's a mod operator. There's a modulus operator. We could use the modulus operator this whole time. That's what I wanted to do. I wanted to do that. So you just mod 10 and you're good to go. You just mod 10. Isn't this the standard way? Probably some non-standard compiler micro optimizations. Okay, gotcha. Quantified quantum. Oh, you saw that OpenAI publication about how to fix AI hallucinations. Yeah, it's actually really cool. I didn't get all the way through it. I didn't. The idea is it has to. Here's. I didn't get through it, but I have a prediction. I have a prediction on how it works. So these LLMs. Thank you for the likes, you guys. Appreciate it. These LLMs, they only have 10,000 answer pool options. So they have so many tokens, right? They only have so many tokens. About 10,000 is the output size. And it gives you a probability of the next token, what the next token is supposed to be. Is so many likes, you guys. Appreciate it. I can see all those hearts animating on the screen. I love it. It's so good. So the LLM, it only has 10,000 output size. So let's check that out. We're gonna branch really quick, Rick. We're gonna branch. Let's clear the screen. Let's reset the canvas. Confirm. All right. So LLMs, they have these basically 10,000. Let me do some copy and pasting. Paste. Here we go. Paste. So look, this is the outputs. Each of these is a token. So it looks like this. Essentially, each of these is a token, and each of these is an option. It's up to 10,000. So X 10K. So there's 10,000 of these guys, right? Because there's 10,000 possible outputs, which is going to represent the next word. That's what LLM does. The LLM inputs a giant window of context, and then it gives you this output of 10,000 tokens. And each of them is a number between 0 and 1, basically. And it is between 0 and 1. And what you do is you find the largest one. So you basically you find the largest. So you find the max. Let's see, number six. You find the max. you say what the max is. And the max is max of the 10K. And whatever is the largest number represents the next word, right? And so when we're talking about hallucinations, the AI has no choice but to give you its next prediction of the next word. It can't say, oh, I don't know, because it doesn't have a token for I don't know. Here, this is my prediction. I did not get through it, but I think the answer is that they add a new kind of token that the LLM can answer I don't know. So they basically a new type of token that is IDK. It's the IDK token. There we go. The IDK token. I think that's what they're doing. I'm guessing. This is me guessing because I don't know what they actually did. But if anyone knows in chat, let me know. Let me know if anyone knows in chat if this is what they did. Drawing Brothers, I replied to a user to access memory. Have you add memory address storing in register? Okay, I think we got through that one. Let's do encryption and cryptography, Drawing Brothers. Yes, let's do it. Okay, we will do that in one of the streams for sure. I promise. Gajana, hey, I can tell you. You can tell me about one of the best stock market performers, and he doesn't know anything about stock markets. Really? Well, why don't you let us know? Don LLM is just an automatic spreadsheet. It is. It really is. It's just an automatic spreadsheet because that's all it's doing. That's all it's doing, you guys. Automatic spreadsheet for sure. Simone, I just found out on ARM64 there is no integer modulo instruction. Oh, is that the case? Thank you for the likes, you guys. It's 100% there in all other CPU architectures. So that's why there's no modulo instruction. That is so silly. That is ridiculous. That is the most ridiculous thing ever. Why isn't there a modulo operator in the ARM in ARM assembly? Why? It's a really I use the modulo operator very often. And so that's crazy. So are you sure you want to continue with ARM? Yeah, I know, right? Because it's such like a fundamental operator, the modulus operator. It's so fundamental. Like, why would we ever continue with ARM? Well, that's because it's what I'm running here on the computer. So, and so, yeah, I guess we want to learn assembly. It would be better if we did it using a different processor. But it's what we got, you guys. It's what we got. So we're stuck. Thank you for the likes, you guys. Appreciate it. You seem to get stuck on the usual things on ARM. Yeah, the complex address calculation, the page offsets, combined instructions, and the naming. You got it. Say, cool. Hey, cool. Guy with sunglasses. Welcome to the stream. Welcome back. We're wrapping up here. We're wrapping up the stream. And so if you guys, we will be doing more assembly. We'll be learning hard assembly. Like Shimon was describing here. It's like, hey guys, we're doing ARM64 assembly, and it's definitely not the easiest assembly. It is not the easiest. What is ARM? Oh, okay. So ARM is a type of it's an acronym, right? So there's different types of assembly. Thanks for all the likes, you guys. I appreciate it. Why is there no good model if AI is good at patterns? Why is there no good model if AI is good at patterns? What kind of model? Wait, which one are you talking about? There's so many models, and there actually are some good ones. Oh, it's a CPU architecture. It is. Cool. Thank you, Drawing Brothers. You answered the question. It's a CPU architecture. So you've got ARM, you've got x86, and you've got, so here we go. So different CPU architectures. It looks like this. All right. So you've got ARM. Let's see if we can, burp. Here we go. Like that. ARM is a architecture 64 assembly. And then we've got, what is it? x86. x86 is 64-bit. And then you've got MIPS. And then you've got, what else have we got? RISC. We got RISC. Is there another one? Here? Let's see. Let's get rid of. Let's see. We probably save. Oh wait, no. Let's get rid of this here. All right. Let's close that window. All right. Is there anything else? Looks like that's it. So these are the prominent ones, you guys. Here we go. Let's close this. Let's get that here. Align that. ARM64, x86, MIPS, and RISC. These are different CPU architectures. They all require a different kind or different set of assembly operators. What you're looking at the screen here is a bunch of different assembly operators for ARM64. And so that's what we're learning. We're learning ARM64 assembly, advanced RISC machine. What do we got? Let's see. Or Acorn RISC machine, because originally made by a company named Acorn. Oh, is it? So Acorn was the company. There you go. Drawing Brothers Stock Trading. Okay. Apple changed the naming meaning of acronym. Oh, did they? Did they? Apple. How'd they? Oh, because of was it? Wait. Was it RISC? Wait, is it Apple? So this is Apple stuff right here, right? Is this Apple? Is Apple here? Was this like back in the day Apple, or am I thinking of the right thing? Is this like Apple in the 90s? Was RISC right here? I think that I'm just guessing. I'm throwing that out, but it sounds like it. x86 is 32-bit. Yep, x86 is 32-bit. You got it. Cool guy with sunglasses. My brain, Dora the Destroyer. I know it hurts. It hurts. It'll hurt. It hurts because you're learning. that means you're learning new things, because your brain is being violent with its synapses, and it's like ripping things, and it's like merging, and like things are working inside your brain, and it's physical activities that are occurring. Your brain is reshaping itself, and it hurts. Don, IDK, what you guys are talking about, my head, but in my head, all I just think is that assembly should be more basic, isn't it? Multiplication, division, and modulo can be replicated by loops. Yeah, I pretty much. But so with assembly, you've got only so much available to you. You've got your instruction set, right? You've got these different instructions, and then you've got registers, which are these right here. So you've got these registers, and then you've got ways to interact with those registers using the operators, and then some variety of symbols that show up here, like the brackets for dereferencing, a pound symbol, the octothorpe, which is for, I guess, literals. I didn't know you could do literals in assembly, but you can. I don't know what this page and page off is, but I think it's based on the page size of the operating system. Things like that. I think that's what that is. Where is Boots Dora? Cool. At Cool, there are various CPU architectures in x86. Oh, there are. So there are different variants of x86s. I thought PowerPC chips was the 90s for Apple computers. Okay, Jack Keeble. Okay, PowerPC. Gotcha. PowerPC chips. I got it. Was PowerPC based on RISC? Let's check that. Let's check that out. PowerPC based on what is it? What is it? Based on what CPU? What CPU architecture is it? Power CPU. RISC. It was PowerPC. You guys look. We're both right. Isn't that cool? Jack Keeble. PowerPC. Based on the reduced instruction set. Isn't that crazy? But it was derived from IBM's Power, which is a performance optimized with enhanced RISC instruction set architecture. Developed by the IAM Alliance, Apple, IBM, and Motorola in the early 90s. You guys, we know our computer history. It's like we went to school and we learned history. All right, we're almost done, you guys. We do have to end here stream in a little bit. We do have to get going. We'll get through the chat messages, and then we'll wrap up our assembly here, and then we'll call it a day. Subscribe if you are if you want to see what the next stream is. There's a lot of cool hard mode programming stuff that we're going to be doing going forward, and that's the plan. That's the idea, because we want to learn. We're learning together, you guys. We're figuring it out. We're figuring it out together. Okay, it was like in the 80s, Don, when it mattered to have small CPUs because transistors weren't as small. Now, new optimized instructions are added for it to run faster. Okay. PowerPC is RISC. Yeah, exactly. Jack Keeble. That's it. Simone, the minimum is add, subtract, and some conditional jumps, load, and store. Okay. So you got to load and store. You got to jump so you can go to statements, and then you can do some add and subtract. That's like the minimum assembly operators. Got it. Everything more was added later. Apple first used ARM in the Apple Newton. Oh, really? No way. Are you kidding me? ARM has been around for that long? I didn't even know. I didn't have any idea. Then they left ARM. They went to Intel with the x86, and then they went back to ARM. So they RISC to ARM to x86, and then back to ARM. What a weird. That's so weird, isn't it? And then iPods and iPhones. Gotcha. When will you be doing more Rust and cryptography? Blue, good question. Okay, so we're maybe next week. Maybe we'll be doing Rust and cryptography next week. I think that would be good. I do like Rust. I do like cryptography. And I think those would be really good streams, really good conversations. And there's a lot to learn there, you guys. Okay, so we got through it. Here we go. I think we have a good understanding. I know SVC is a service call to the operating system that says call x80, which is print. I believe this is print to standard out. So we're printing to standard out here. Anyone else learning Flutter? Don the Don. And Dart. Dart is the language, and Flutter is the, I think, multi-platform UI, right, for mobile app development. I only know about Flutter because we have an SDK for Flutter at PubNub, and that's how I know. That's all I know about Flutter and Dart. It's an ECMAScript-based language, right? Dart is an ECMAScript language. So it looks kind of like JavaScript, but it's maybe more like TypeScript, really. It kind of looks more like TypeScript, I think. Okay, you guys, and then I think that's it. Is that everything? Here, let's go. Let's see if we could build and run. All right, so we've done it. We've built and run. Can we do one last thing? So we've got a loop here. We've got a loop happening. So loops here. It loops here. It never exits. How exit loop if counter is greater than or equal to 5. Is that, we can't say exit program. We cannot. How do we exit? How do we break? How do we break? Compare. How do we do this? Actually, I don't know. This is something I want to do. If we can do this one last thing, then we'll end stream. How do we exit the loop? How do we do it? CNM. Hey, how's it going? Is Terry Davis the perfect patron saint for programmers, hackers, etc.? Terry Davis. Wait. Who? Wait, Terry Davis, hacker. Let's find out. Terry, did I spell Terry right? I got to tell Terry Davis, hacker. Terry Davis. Terry Davis was a brilliant self-taught programmer, engineering for creating the operating system Temple OS. We're learning new things, you guys. While battling schizophrenia. Oh, he is not considered a hacker in the traditional sense. Rather, he was an outsider artist and a programmer, single-handedly built an operating system on his own programming language. Holy C. Oh, I remember this. You guys. Holy See, to communicate with God as per his religious delusions. His work is seen as both unique and fascinating achievement in software development and a tragic story about his struggle with mental illness. There you guys go. Learning a little bit more things for everyone. Hey, Stephen. Hey, how's it going? Happy to have you here. Christopher Smith, you used Flutter, but you think Kotlin multi-platform is the way to go. Yeah. I think Kotlin multi-platform is like the next level. It's like the next generation. It's where we are now. Use Kotlin multi-platform. Flutter came out a little bit longer ago, as well as Dart. Flutter is also into issues with Apple's new Liquid. Oh, is it? So Flutter has some new issues with Liquid Glass coming out. Got it. They'll probably fix it, but it makes Mohammed, you worked with Dart. It's more like Java syntax. Okay, gotcha. It's instead of being more like TypeScript or JavaScript, it's more like Java. That makes sense. There we go. Break is just another branch. Break. Okay, so we do B break or something like that. Do we say break like that? Something like that. So we could say B break. But how do we do that when we do that? How do we say conditional? We need to say, hey, millionaire, Chromer, hey, how's it going? Happy to see you. We're right here at the end of stream. We're doing one last thing. Before we go, we need to break the loop because it's looping forever, and I want to break it. We did the thing. We figured out how to convert a number to a string the hard way because we're using ARM64. And Vitor Lisboa, hey, what we're doing ARM64. We're just wrapping up stream, so we'll be live tomorrow again. So subscribe if you want the notification, and we'll be live tomorrow. No semicolon is ARM. No semicolon is ARM. ASM is ASM. Sorry, got to read that correctly. No semicolon is ASM. In ASM. Okay, there is no semicolon, right? Yeah, so we don't need to use semicolon. It's all, I guess. It's not even, you can, everything, there's white spaces just for the humans, right? The space is just for humans. Thank you for likes, you guys, appreciate it. He made a cult. Yeah, he did, right? So the Temple LS programmer, Terry Davis, he definitely made a cult. I remember seeing some of that operating system. It was crazy. It was unexpected stuff in there. Okay. Here we go, guys. We need to break. So B loop here. So if we say B break, what? So let's just try to break here. Let's see. So instead of looping, we'll jump past the loop. No semicolon. You said line 83. You saw I put a semicolon. Before I even run it, you saw. Yep, I put a semicolon right here. We don't need semicolons. It's habit. You run into habit, you guys. It's habit. All right. Let's see if it builds and runs. Okay, so we were able to jump past this loop, but I want to conditionally jump. How do we do that? How do we do that? How do we conditionally jump? X compare 5. How do we do that? I don't know. I don't know how to do it. I really don't. Does anyone know? Brain is another level of guess. Oh, so there is a language. Don, you're right. There's another language called brain expletive, right? It's the brain expletive. It's a language that is all symbols, and it is very difficult to read. But it is built specifically to be difficult. They built it on purpose to be hard to use. Cromer, I use VS Code as a lightweight and cool AF. You use VS Code and it's lightweight and cool AF. Yeah, it is. VS Code is great. It's a great code editor. It is absolutely wonderful. I never use JetBrains or any other IDE. I use Jupyter Notebook though. Yeah, Jupyter Notebook is great, especially for Python, and we're using data frames and pandas and maybe Scikit, or maybe you're using TensorFlow with Keras. These are great ways. Okay, if you want to conditional execute, you first need to use compare, which we did. We did CMP to check if your register is bigger or smaller than some constant. So we did, like 5. Okay, so we did that. Simone, thank you. Oh, thank you. All right. Then you can use B, a version of B, to branch BEQ. BEQ. Okay, so BEQ. BEQ break. So, but, it needs to be, okay. We're almost there, you guys. Use branch BEQ, branch for the result of the last compare was equal. Or BLT if the last result compare was less than. Whoa. Really? Really? So, are you telling me if you want more versions of conditional execution, check out ARM condition code table? Okay. Here you go, guys. Here you go. So, are you telling me that this is it right here, that this will work? This will work. So this will get us out of the loop. This will get us out of the infinite loop. Is that what you're telling me? After how many streams? It's 5 streams now, 5 days of streams. This will get us out of the loop. Okay. Coding a web server directly in assembly is possible. It is. It is, because you can directly interact with the operating system's input outputs. So you can use, so we're using standard out, which is number 1, and then standard error is number 2. So what? And then everything above that is a file descriptor that is meant for, you can write to a socket, for example, so you can do network communication directly here in assembly. You can do it, you guys. It's really cool. I think that would be a hard mode thing to do for sure. Everyone uses VS Code, isn't it? Yeah, Don, you're totally right. VS Code is the most popular IDE. All right, you guys, here we go. This is it right here. This will end our stream if it works. If it works, we're ending stream. And 1, 2, 3, 4, 5. Oh, it works. Shimon, look, you did it. You did it. Thank you. Oh, that's so cool. Oh, we did it, you guys. It exited hello world, increment, and then conditionally branch, and it breaks here. Isn't that cool? BEQ break. We did it. We did it, you guys. That is so cool. All right, you guys, thank you. All right, so we succeeded with the help of Simone. Thank you, you guys. Thank you for all the likes. We did it. We did it. We win. We win at everything. Okay, so those who don't know, this guy owns a company named PubNub. Oh yeah, thank you. Thank you for mentioning Cromer. He is already a millionaire. That is, yep, you're giving away information. You're giving away information, Cromer. You're letting people know things. Don, really? Yes, it's true. All right, so let's check that out real quick. Let's look at PubNub. All right, so pubnub.com. Here we go. This is my company. We have over a bro Steven. Yeah, there you go. That's me right here. You got it. Bro Steven. Here we go. 1 second. Oh, no, okay, we're good. We are good. We are good. Okay, cool. Check this out, you guys. Bro Steven or other people. Yeah, so here, this is my company. We connect multiplayer games. We do chat. The top 10 apps in the App Store, they all have built-in communication, and that's what we provide. We provide built-in communication. And that's Bro Steven, yeah. Or other people. Yes, and other people. And other people. You got it. Yeah. And so you own the company. You got it. You've got the right answer. Christopher Smith. Yep. And it's been a wild ride because C++. Irfan Dunst. Yes, Irfan Dunst, C++. Actually, PubNub is written in C. You guys, it's written in C. I wrote the language while on a plane about 15. Is it hard to learn assembly? Yes, it is. We are King Conic number 1. It is very challenging, but it's a lot of fun. It's a lot of fun to learn assembly. So we started this company in 2010, and it's been a big adventure. In May 2023, we exceeded 1 billion connected devices on the network. And so we we connect games for multiplayer. We do entertainment. We do healthcare. So Teladoc, right? If you use Teladoc or if you use any other telemedicine app, they use us as well. Swiggy as well. Yeah, Cromer, Swiggy too. You got it. How do you know that? Cromer, how do you know that? How do you know this? Oh, because you saw it on the screen maybe? Did it show up here on the screen? It might have shown up on the screen. But yeah, Swiggy, you got it. That is one of them. Is popular food delivery company in India, dude. It is. Guys provide a service. Yep, you're right. You got it. That's us. You figured it out. Sean, what are you doing today? We're at the end of stream, and we're just answering some questions from chat here really quick. We're answering some questions in chat. We figured it out. We did all the things we wanted to with assembly. Check it out, you guys. It runs, it builds, and then it conditionally exits. So we printed the string. That's a number. We converted a number to string. We printed it out. We printed hello world. We iterated in a loop, and then we conditionally broke with BEQ right here. Isn't that cool? I love it. And then so we're answering some questions now right before we end stream. Yep, Swiggy right here you see on the screen, Swiggy, and Adobe and Unity. You guys, we're everywhere. We did it. So cool, brother. All success to you in PubNub. Thank you. Yeah, this is my company. For older CPUs, it can be easy. Yeah, it is. It's a lot easier. So what Simone is describing, when you're learning assembly, use older CPU instructions because it's a lot easier than what we're doing because we're using ARM64, and it was very difficult. If you want to make optimal code with modern CPUs on top of an OS, it can be hard, and that's what we're doing. We're doing very hard things right now. Wow, bro, you're really cool. Thank you, Jack. Thank you, Jack. Appreciate it. That's really good. Oh, have a good day, y'all. Sean, yep, we're wrapping up here. So subscribe, you guys. Subscribe if we'll be heading out here, and we'll be back tomorrow. We go live at various times, but I have meetings throughout the day, so I can't always go live at the same time. So it's easy if you subscribe. We also have a Discord channel. Let's bring that up really quick. So we'll copy paste that in. So join the Discord channel, and we also talk about next topics, upcoming topics, and things like that when we go live as well. Joshua John, is the intent of your business for profit or service? Both. It's both, you guys. It's for profit. We're for profit business. We provide an API to allow communication. So you just go to our docs here, and then say you start something like JavaScript, and you look, and then so you initialize the SDK with your API keys, and then you add a listener, and then you subscribe to a channel, like Hello World. You say Hello World is our channel, and then you publish a message to the channel Hello World. There you go. And then anywhere in the world, thank you for your likes, you guys, appreciate it. Anywhere in the world where you see, where any device is subscribed, King Conic 1, nice channel, thank you, appreciate it. Speaking of channels, when you subscribe to a channel on PubNub, you're subscribing to that channel, and then anywhere in the world, when a message is published on that channel, you will receive that message. Whether you're running on mobile, on your Android, on your iPhone, on a smart controller or smart device, there you go. Thank you for likes, you guys, appreciate it. You guys can check his name on Google. He has a lot of patents. Yeah, that's right. I do. We've got a lot of patents. So you can even go Google patent search, and we go PubNub Stephen Blum, and it will figure it out. Here we go. PubNub. Let's do PubNub. PUBNUB. Here we go. Patents assigned to PubNub. Here we go. Check this out. Check out the patents. We got some patents, you guys. Let's see if it loads. Oh, wait. Is that the right one? We want to do Google patents. Here we go. Let's see. Actually, you know what? We listed out all the patents here. So we do. We really have patents. We really do have patents, you guys. Check this out. Check it out, you guys. We got some patents here. Where'd they go? Here we go. So distributed transmission of messages. That's a good one. I think that's a really good one, don't you guys? I think that's a really cool one. That means that we've got the patent on communication. I like that one. And it's for a very specific type of communication that's durable. I like that one. Then we also have a patent for detecting latency. I like that one. And then we've got another one for replication, data replication. We've got distribution, another kind of a patent. And then we've got data synchronization patent. Yeah, I've got a lot of patents, and they're all real. So you can click on them. You can see here, they go to Google, and you can see the patents. And so there you go. There you guys go. Isn't that cool? So jumping back to it here really quick. I think that answers your questions. I think that answers all of everyone's questions. So we're wrapping up stream now, you guys. Thank you for hanging out. Dude, you literally made it in this space. I'm so jealous. Christopher Smith. I know. That's it was not easy. It's very challenging. It's very hard. But you know what? Here's the deal, you guys. You all can do it too. It is persistence. Continuous persistence. You got to do it. That is so cool. Shyam, yeah. Thank you for the likes, you guys. Thank you for all the fantastic, wonderful things and comments. I appreciate it. It was a lot of fun hanging out with you today. We'll be back tomorrow. And we'll be doing some more, maybe doing some more assembly, probably doing a little bit more assembly. We'll figure out like what the next thing is to do. But if you join our Discord here, we'll have more topics and we'll figure things out there. He doesn't even use a car. You guys, yeah, Cromer, you're right. He doesn't have I don't have a car. I have a place to put a car, but I don't have a car. Hey, Priya, how's it going? Welcome into the stream. No. Okay, have a nice day, everyone. Thank you, everyone, for hanging out. Subscribe if you want to know when we go live next, because we'll be live tomorrow. And then we'll be doing some more code reviews. We're doing hard mode stuff, you guys, seeing how it goes. But yeah, have a good day, everyone. Thank you for hanging out. We'll be chatting more in the next stream. Have a good day, everyone. It was fun to hang out with you. See you guys next time. All right, here we go. Thanks. We'll catch you at the next ones. Cool, Christopher. See you guys next time.